Hey everyone, this is Darshan Senthal. In this video, I'm going to be talking to you about trigonometry-based vectors, because trigonometry has to influence every part of our lives. Just kidding. But it's not that hard, to be honest, if you just know your basics well. So, I'm just going to guide you through this, okay? Just stay with me. So, let's get started. So, vectors can be used with trigonometry as well. Pretty basic. Now, trig vectors can be symbolized using the following form. Cosine theta and sine theta. Okay, so this is what you can use to symbolize a vector using trigonometry. So what is m? Well, m is going to be the magnitude of the vector. Okay, m is going to be the magnitude of the vector, and theta I'm going to get to it later. So when would you use this kind of thing? Well, I'm going to get to that right now. So let's just let's start deriving this. So for example, let's say we had a vector here, okay, and we knew its magnitude. Let's give it a magnitude m. So let's say we know the value of this m, okay? Now, but we don't know the x component or the y component. We don't know x or y. We don't know either of these. But what we do know is we know this angle of the horizon of the x-axis. This angle theta, we know that angle. So what can we do now? How can we find the lengths of these two sides? Well, let me show you how. So I'm going to call this side A and this side B, and I'm going to show you how you can solve them. So using this angle, what trig function can you relate to side A? You can use cosine, right? So you can say that the cosine of theta is going to be side A over m over your hypotenuse. Okay, so I hope you see how I'm doing all this stuff right here. And now what trig function can you use to relate to this side right here? Well, you can use sine, right? It's opposite of our hypotenuse. And if you don't remember this stuff, I recommend you going and watching my intro to trigonometry video again. So either way, let's keep going. So sine of theta is going to equal opposite over hypotenuse. Okay, and now I want to know the length of just that side right there. How am I going to do that? Well, here's what we're going to do. So we're gonna just basically multiply both sides by this hypotenuse length right here. We're going to multiply both sides of these equations. So I'm going to multiply this side by m, and I'm going to multiply this side by m. So the m's cancel out. I'm going to do the same over here. M's cancel out. So what I'm left with, m cosine of theta, m sine of theta. Okay, so, and those would be my x and y components of the vector. So my x component would be m cosine theta, and my y component would be m sine theta. And when would you use this? Now, as you can see, you would use it when you don't know these x and y components. Okay, so you would use this when you don't know the x and y components. Use it to split it up into two components like this, okay? And you might have guessed this by now, these two are called the components of the vector. Okay, so important stuff, okay? Hope that helped. And now let's move on to some example problems. Okay, let me just get rid of all this stuff. So let's say here a ball is traveling at 370 meters per second at an angle of 40 degrees above the horizontal. Find the vertical and horizontal components of the vector. Okay, so let's just draw a triangle here to get us started. So we have a ball here. It's going up at 370 meters per second, and it's going up at an angle of 40 degrees. Okay, so we want to know what this is and what this is. Okay, so all we need to do is just set it up again. So what trig function relates the x and the hypotenuse? Cosine. So, and if you remember, x is going to be equal to 370 cosine of 40. It's going to equal x. Okay. And what trig function relates theta and y? Well, it's going to be sine. So 370 times sine is equal to 40. Now 40 is going to equal y. Now you could go ahead and type that into your calculator, and if you did, what you would get is you're going to get 283.44 meters per second. And if you type this into your calculator, you would get sine of 40 is going to equal 237.83 meters per second. Now you could just leave it like this, or you could write it like this based on what you need for your specific test or quiz or whatever. So this is the more accurate answer. Well, this is the more practical answer. Okay, so you decide which one you want to use for your particular problems. Okay, so that's how you would make components of vectors. So I hope you've got that clear, because that's going to be really important for our next problem. Okay, let's get rid of sorry about that. So you are pushing a cart with a force of 52 newtons at 11 degrees above the horizontal. So word problems, again, these will be really important if you do physics in the near future. So your friend comes to the rescue and pushes with an additional force of 60 newtons at 15 degrees above the horizontal. Find the following: A, the vertical and horizontal components of each person's force vector, and the net force that the two exert on each other. So what this means is that in the end, we're going to have to add the vectors, okay? So first, let's just write out the components. So for the first guy, I'm going to write it out in red. So for you, again, if you want to draw out a triangle, that's perfectly fine. It's going to be this is not on a scale, by the way. So this is going to be 11 degrees, 52 newtons. So again, I'm not going to go through the whole explanation, but again, what trig function does this and this, that you're going to get, your components are going to end up being 52 cosine of theta of 11 in this case, and 52 sine 11. Okay, so that's what it's going to end up if you just like use your function. Okay, and now what about for the second guy over here? What about for your friend over here? 60 newtons at 15 degrees of the horizontal. So what we're going to do is we're going to break that into components as well. You can draw a triangle if you wish, but for time's sake, I'm not going to. Oh, that's 15. Sorry about that. It should be 15. Okay. And now you could just add the two and you get an answer. So if you added them in your calculator, you would get that would be about 109.001, repeating something, and excuse me, 25.45 something. So these would be your two components. Okay, and if you notice, now we need to add them. Okay, so to get the net force, we need to add them, and we've already got that. So now what do you notice that we have over here? We have two components, right? And now we need to put them together and find the magnitude and direction of the force, just like this. So 60 newtons at 15 degrees above the horizontal, 52 newtons at 11 degrees. We need to find something like that. Okay, so here's how we would do that. So think of these as being like two sides of the triangle. So say this is about like 109 and this is 25. Okay, so we need to find this and this. So how do we find this? Well, Pythagorean theorem. Oh, and by the way, just as a side note, when you use these kind of things, you get like these really long decimals. So what I'd recommend you do for maximum accuracy is to store these values. So I'd store this one as x, I'd store that one as y. Okay, that's what I'm going to do for this. But I'd recommend you do this in your calculator as well. Store them as whatever variable you want, but make sure you store them for maximum accuracy, okay? So I'm going to do, for magnitude, I'm going to get x squared plus y squared. That's going to be equal to 111.9 newtons. I'm not done yet. I need to find the direction of this vector. So that I'm going to use theta. And what function relates these two sides to get you an angle? Well, it's going to be inverse tangent, okay? Because a tangent is what would give you the ratio between these two, and using the ratio between these two, getting the angle, is what you can use inverse tangent for, okay? So inverse tangent of y over x, which is going to give you 13.14 degrees above the horizontal. I'm running out of space here. You get the idea. Okay, so this is what your final answer should look like. You should have a magnitude and you should have an angle below the horizontal. And the reason this is above the horizontal is because both your x and your y are positive. Okay, so that's the end of this video. I hope you found it helpful, and please do subscribe to my channel, check back for more videos, and I'll see you later. Bye.